Which two jobs are performed by lipids? The answers are energy storage. Triglycerides store energy, and they form cell membranes. Phospholipids do that. Okay. Starch formation is the role of carbohydrates. Histamine and neurotransmitters are associated with amines and amino acids. Question number 2. Which two molecules are hydrolyzable lipids? The answers are waxes. Waxes are esters with long hydrocarbon chains. And C, triacylglycerols or triglycerides. Those are hydrolyzable. They can be broken apart with water mechanisms. Steroids, prostaglandins, and vitamin A are non-hydrolyzable. Question number 3. Rank the following molecules according to melting point. Enter the name of the compound with lowest and highest melting points. The lowest melting point, that is something that is most likely to be a liquid at room temperature, is another way to think of it, is linolenic acid. The lowest, it's got the most number of double bonds in it. And the highest melting point is going to be the molecule that has the least number of double bonds in it, and that's stearic acid. Stearic acid is a saturated fatty acid. There are no double bonds in the hydrocarbon chain. So this portion, no double bonds. That's why it's saturated. Both oleic and linolenic acid have double bonds in the hydrocarbon chain and unsaturated. Consider the figure describing transport across a cell membrane. Label each blank as either facilitated transport, diffusion, or active transport. Blank 1, corresponding to this, is diffusion. Carbon dioxide, oxygen, uncharged small molecules can diffuse through the lipid bilayer, the cell membrane. Sorry about that. Phone call. So again, pick up. This is diffusion. Two, there's a membrane protein, integral membrane protein, allowing substrates into the cell. So that's facilitated by a protein, so it's facilitated transport. They do make better styluses now. Facilitated transport. And then lastly is active transport, because energy is needed to transport this substrate against the concentration gradient from low concentration to high concentration. That requires energy. That is active transport. It's active. Question number 5. High-density lipoproteins, HDL, transport cholesterol from the blank, so liver, tissue, or stomach, to the blank, and is considered blank cholesterol. So HDL is good, quote unquote, good cholesterol, or a proxy for cholesterol measurement. And LDL, of course, is bad or lousy cholesterol. So good cholesterol, that is HDL, transports cholesterol from the tissue to the liver. So that prevents, or certainly diminishes, the buildup of cholesterol in the vascular system. The reason that it's good is it takes it, cholesterol that is, HDL, takes cholesterol from the tissue to the liver, and it's healthy or good. Question number 6. Identify the prostaglandin molecule. The answer is D. The 5-membered ring is the characteristic of a prostaglandin. Above, this is an unsaturated carboxylate salt, or an unsaturated fatty acid salt. This is a phospholipid, so it contains phosphorus, and this is cholesterol, but cholesterol is a category of steroid. It's characterized by this 4-membered fused ring system. Question 7. Classify each molecule as an aldose, ketose, or neither. Molecule number 1, or the leftmost one, that is a ketone functional group, so a carbonyl between 2 carbons, and then it's a carbohydrate, polyhydroxyl, polyalcohol 2. Number 1 is a ketose. CHO, that is the condensed formula for an aldehyde. So it is an aldose. And 3, well, it's just an alkene from way back. Nothing but carbon bonds, carbon-hydrogen bonds. There's one double bond there, but nothing else. So it is neither. An aldose or a ketose. Question number 8. Classify the carbohydrate below. Well, with the answers, they're all hexose, so they also have 6. This does have 6 carbon atoms. 1, 2, 3, 4, 5, 6. So yes, they're all hexoses. And then alpha or beta. The reference for whether this is alpha or beta is the carbon indicated here. This is a hemiacetal. So you've got oxygen, carbon, oxygen, hydrogen. So it's a hemiacetal, that position. And since it's down is anti, or alpha. So we can eliminate the choices that have beta linkages. The hydroxyl group, the OH group, would be up in those instances. So aldo or keto, how you tell that? referencing the hemiacetal. The reference is those R groups they're the groups that are not oxygen. So oxygen, oxygen. Here you have a carbon. Here you have a hydrogen. This hydrogen tells you that it's an aldose. So the answer is A. An aldohexose. We're an aldehyde. Is that general abbreviation. So the tel, this hydrogen, when this is an open chain form, the anomeric carbon would look like this. Now it would be an aldehyde. Question number 9. What is the most common ring size when the molecule below undergoes cyclization, or it's converted into a ring? So here you identify the anomeric carbon. That's the carbon that's the most oxidized one. It's got the carbonyl. That's the anomeric carbon. And you identify the chirality center that is the furthest away from it. So here. So the oxygen atom will attack the anomeric carbon to close the ring or to form a ring. And if I count the number of atoms that would be in that, 1, 2, 3, 4, 5. It's 5, it would be a 5-membered ring. Question number 10. Identify the 2 anomeric carbon atoms in the molecule below. So the anomeric carbons are the carbons that are either in hemiacetals or acetals. So your eye should be drawn to where the oxygens are. There's an oxygen here and here that are bonded to, or you should be drawn like a carbon that's bonded to 2 oxygen atoms. And this carbon's only bonded to 1 oxygen, carbon, carbon, hydrogen. So here and here, oxygen, oxygen. So the choices, those are the only 2 that are acetals or hemiacetals. C5 is an acetal, oxygen, carbon, oxygen, carbon. So that's one of them. And then C1 is a hemiacetal, carbon, oxygen, no H group, an oxygen bonded to carbon. It's a hemiacetal. Those are the anomeric carbons. So those are what change can open or close, can be cyclized or be opened to form a straight chain. Question number 11. Match the Fisher projection to the correct beta anomer Haworth projection. So the question is asking about betas. So we can eliminate the alpha positions. The hydroxyl is down. The hydroxyl is down. So this is alpha, alpha. We can eliminate those here. Up, up. So the carbons that we got to look at remember, the right is down, the left is up. If you picture rotating this to the right to match. So we look at our choices. So we should have hydrogen, number, should number, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, so 2 should have a hydroxyl that's up. Yep, up, up, down, down, and then 2 hydrogens down, hydrogen up. The answer is B. And D, it's your first position. You've got the hydroxyl down, should be up. That's why D is incorrect. Question 12. Which carbohydrates are polysaccharides? The answers are A, cellulose, C, glycogen, and D, amylopectin. Those are all polysaccharides. Maltose and sucrose are disaccharides. Question number 13. Which statement about the figure below is true about donating and accepting blood? Okay, you may need to scroll to view the entire figure. On the actual exam, soft exemplify exam, that may be true. So we examine these. Type O is the universal blood acceptor, and type AB is the universal blood donor. The idea is, with blood typing, is all the blood types have this core. AB would have this core too. So AB would have both this carbohydrate and this carbohydrate. Okay, AB, type AB would have both of those. So if you have these carbohydrates, that means that you aren't going to have a reaction to them because you have them. Okay, you don't have antibodies against these because they're normal. They're part of your normal biological, biochemical makeup. So type O, if you were to give type A or B blood or type AB blood to type O, since these carbs aren't present, well, it would kill the person, to be dramatic, but it's true, because there would be a massive immune response to these sugars because they're not, well, I should say carbohydrates, because they're not normally there. So type O cannot accept just any old blood. Type O is a universal blood donor. Okay? It's not an acceptor because if a person with type O blood were exposed to these carbohydrates on those blood types, you would get a massive immune response. And so type O is not a universal blood acceptor. That would be AB. AB has all the carbohydrates listed above, so it has no antibodies against them. Therefore, it can receive blood from A, B, or O. So if you've got type AB blood, you're in luck for if you ever need a blood transfusion. So the answer is B. But since type O is the universal blood donor, because all blood types have this core, so if you donate type O blood to these individuals, and type AB as well, they're not going to have an immune response because they do have these carbohydrates as part of their blood type. It's a long answer. Type O is a universal blood donor. Anyone can accept type O blood, but type O can only accept type O blood. AB can accept blood from any blood type.